Let's see a question from differential equation. We need to solve this differential equation using Laplace transform. So let's start. So what we do in this type of question, the first step is to take Laplace transform on both sides. So if in the initial equation which is given, if we take Laplace transform on both sides, what you will get? You will get Laplace of d²y by dt² plus two times Laplace of dy by dt plus 5 times Laplace of y equals to Laplace of e power minus t sin t. Fine. Now for this question, for the sake of simplification while writing, I will write the Laplace of y as y bar, just for the sake of simplification. Now what is the formula of Laplace of second derivative? I have already discussed in previous videos that Laplace of f double dash t. How we find this? What is the order of derivative? Second derivative. So start with s power order of derivative. I am telling the trick to learn this formula. So start with s square and we will go up to s power 0. Okay. Now in first term multiply with Laplace of f of t. Only first term will be positive, rest all terms will be negative. In second term decrease one power, so s, and in second term multiply with f of 0, and from third term onwards it will be derivative. So third term will be s power 0, which is 1 into first derivative. Okay. Because s power 0 we have got, so we will stop here. So only 3 terms. So we will apply the same here. F of t here is y. So it will be s square into Laplace of f of y. So Laplace of f of y, that means Laplace of y, I have already told that I am assuming that as y bar, so s square y bar. Second term is minus s f of 0, so y of 0 here. Third term is f dash 0, so y dash 0 plus 2 times Laplace of dy by dt. So if we use the same idea, Laplace of f dash t, what will that be equal to? Now you try to write this yourself. Order is 1, so you will start with s power 1. First term always Laplace of f of t. In second term decrease this power of s and a negative sign is there, so it will be s power 0. And with second term we always have f of 0, so only 2 terms will be there because s power 0 we have got. So this will be 2 times s will be there of course, and Laplace of f of t, that means Laplace of y, that I have assumed as y bar. Second term is minus f of 0, that means minus y of 0, plus 5 times Laplace of y is again y bar, equals to Laplace of e power t sin t. So first shift we will use, first of all we will find Laplace of sine t, which is a sine at. Laplace of sine at is a divided by s square plus a square. Now because we are multiplying by e power minus t, so if we multiply by e power at, what happens? In this replace s by s plus a. So 1 upon, will replace s by s plus 1. So if you want to simplify this, 1 plus 1 2 and 2s. So s square plus 2s plus 2. Okay. So this is 1 upon s square now. We'll use these two values also. So y of 0 is 0. So this term vanishes. Y of 0 is 0. So this term also vanishes. Y dash 0 is 1. So we are getting minus 1 here. Isn't it? And from the rest we can take y bar common. So we are getting s square plus 2s plus 5, and the y bar is common, equals to this minus 1. If we'll go to the RHS, this will become 1 upon s square plus 2s plus 2 plus 1. Okay, so if you simplify this bracket, let us simplify it here. So this will be 1 plus s square plus 2s plus 2 divided by s square plus 2s plus 2. So this is giving us s square plus 2s plus 3 in numerator and s square plus 2s plus 2 in denominator. Okay, so I can erase this, or let's move to the next page because it will be required. So we have s square plus 2s plus 5 y bar this y dash 0 is 1. Okay, so y dash 0 we have, I send that to the RHS. Fine, so no problem. Let's move to the next page. So we have s square plus 2s plus 5 with y bar, this equals to 1 upon s square plus 2s plus 2 plus 1. So that was giving me with simplification. I am writing the simplified part now. This plus this is your simplified portion only. So I will writing s square plus 2s plus 3 in numerator. So s square plus 2s plus 3 in numerator divided by s square plus 2s plus 2 in denominator. Fine. Now what we can do is we can get rid of this term from LHS. and this will give you s square plus 2s plus 3 divided by s square plus 2s plus 2, and you are getting an extra s square plus 2s plus 5. So this you are getting as y bar. Now carefully think that how to resolve this partial fraction. First of all, we have to take Laplace inverse on both sides. That is the first idea. Then we'll move to the partial fraction portion. So if we take from here, take inverse Laplace transform on both sides. So Laplace inverse of Laplace of y, so that will give you y only, equals to Laplace inverse of this whole thing. Now we'll stop the proceedings of Laplace here and we'll go to resolve this partial fraction, which is s square plus 2s plus 3, s square plus 2s plus 3 divided by s square plus 2s plus 2, s square plus 2s plus 2, and s square plus 2s plus 5. How to resolve this? Now first one will be as plus b divided by the first bracket, which is first quadratic expression s square plus 2s plus 2, plus cs plus d, and the second bracket, which is s square plus 2s plus 5. Fine. Now we can simplify it one more. Now patience starts here because I am solving it slowly so that you can understand it better, because this is some lengthy portions which is coming up. S square plus 2s plus 5 equals to, now cross multiply, so we'll get as multiplied by this, so I am taking s inside, so you'll get s cube plus 2s square plus 5s plus b multiplied by this, so b times s square plus 2s plus 5, cs multiplied by this, so again I am taking s inside, so s cube plus 2s plus 2, and finally d times s square plus 2s plus 2. Now I don't never want to write the denominator because that is anyway going to cancel, but just for the sake of formality, s square plus 2s plus 2, s square plus 2s plus 5. Okay, now you can see easily this is getting cancelled. So what I am doing is, I have shown you how to cancel this. Now I am erasing this because I don't want to write one extra step here, so it is better to erase this because this is getting cancelled now. Okay, now we have got rid of the denominator portion because that is already cancelled. Now we can move ahead with the simplification. Just we need to compare the coefficients on both sides. So if we look at coefficient of s cube, so in LHS coefficient of s cube is 0, but in RHS there is some coefficient. So what is there? A from here, let me use different colors for different coefficient, that will be interesting. So violet first. So for s cube we have A plus C, but in LHS the coefficient of s cube is 0, so we will be getting 0. Now if we look at the RHS, it is s square. So let's compare the coefficient of s square. So in LHS it is 1, in RHS it is 2a plus b plus d. So 2a plus b plus d, 2a from here and b from here and d from the third bracket, and that is equal to 1. And now compare the coefficient of s. So if we compare the coefficient of s, so s is 5a here, 2b here and 2c here, and we are getting a 2d at the last. So this is equal to 2. Now if we compare the coefficient of the constant term, so constant term is 5b from the second, 2c and 2d, and that is equal to 3. Now start solving this. So as you can see clearly, a equals to minus c. Now because a equals to minus c, in this equation if I see, we have 2c, we have 2d. So five a is also there. So if we put a equals to c, a equals to minus c, let's check whether the equations are correct or not. Coefficient of s square we needed, that is 2a plus b plus d. Now 2a plus b plus d. If we look at this, what was this? Coefficient of s square. So s square coefficient is 2a from here, b from here, and why are you not getting any s square term here? If you multiplied this, you would have got c into s cube plus 2s square here. Oh. So this I think made problem for us, because an extra 2c will also come in this. So if we erase this, then extra 2c must also come, and d was always there, equals to 1. So first equation is a plus c is 0, second equation is 2a plus b plus 2c plus d equals to 1. Third equation, 5a plus 2b plus 2c plus 2d equals to 2. Fourth equation, in which again would be incorrect because we made some changes. So look at the constant term now. Fourth equation was for constant term. So the constant term, we are getting 5b from here, and this will be 2s again. This will be 2s. So constant term will be just 5b plus 2d only. Okay, and coefficient of s, it is 5 from here, then 2b from here, then 2c from here, and 2d from here. Fine. Now we are done with the equations. Let's solve this because it have already taken us a lot of time. So a equals to minus c. So if you look at this equation, so we can take 2 common. So this will become a plus c plus b plus d equals to 1. A plus c is 0, so this will become 0. So we are getting b plus d as equal to 1, and we have 5b plus d. From here, b will be 1 minus d. Let's put that in last equation. So 5 times 1 minus d plus 2d equals to 3. So 5 minus 5d plus 2d equals to 3. So we are getting 2d minus 5d minus 3d. If you send that side and 3 this side, so 2 equals to this was minus 3d equals to 3d. So you are getting d as 2 by 3. Now d as 2 by 3, if you are getting, then from this equation b will be 1 minus d. So 1 minus 2 by 3. So that is 3 minus 2, 1 by 3. So far we have got two values. First, the value of d we have got. It is important again to use a different color so that we can identify it later. So value of d, value of b, two values we have got so far. Let's move to the other values. So b and d values we have got, and again I am coming to the third equation now. In third equation, in first and the last term, if I take 2 common, so I will get 5a plus 2c is there, and I am taking 2 common, b plus d equals to 2. B plus d is 1, so this will become 2. So 5a plus 2c equals to 2 minus 2, so 0. Okay, and also a equals to minus c, so minus 5c plus 2c equals to 0. So from here you are getting c as 0. So when c is 0, a will automatically be 0, so a is 0. So a, b, c and d. So we have got all the 4 values correctly. So a, b, c and d I have got. So this is a big breakthrough for us. So we can come back here, and because this c and this a is 0, we have b upon this and d upon this. So moving to the b is 1 by 3. So this was there. So y equals to Laplace inverse of b is 1 by 3 and s square plus 2s plus 2 plus this is d, which is 2 by 3 s square plus 2s plus 5. 2 by 3 s square plus 2s plus 5. Now we have two complete squares. Okay, so if you look at this first one, so y equals to Laplace inverse of 1 by 3, s square is fine, 2s is fine. Now half of 2 is 1. Okay, so we have to add square of 1, which is 1, and subtract that 2. Plus 2 is already there. Plus 2 by 3. Again s square plus 2s is fine. Again add 1, subtract 1, plus 5 is already there. So y equals to Laplace inverse of 1 upon 3. Now this is s plus 1 whole square, and 2 minus 1 is 1, so I can write that as 1 square. 2 by 3. Again s plus 1 whole square, and wait, this will create confusion for you, because this 3 it is better to take out. So let's break it into two Laplaces. So first one, Laplace inverse of 1 by 3 I have taken out. So this was coming out to be s plus 1 whole square plus 1 square plus 2 by 3 Laplace inverse of 1 upon s plus 1 whole square again, and 5 minus 1 is 4, which is 2 square. Okay, fine. Now you use the first shift. So we have moved from this you can basically think as 1 upon s square plus a square. So Laplace inverse of 1 upon s square plus a square is nothing but 1 by a sine 80. And if we want to find Laplace inverse of, if you are replacing this s by s plus 1, so if you are replacing by s plus 1, so this will basically become e power, because here it is plus, so minus 80, a here is 1, and sine of 80. Okay, fine. So y equals to 1 by 3. So this will become e power minus t, because this is s minus minus of 1, so a here is minus 1, and sine of at divided by a is also there, sine of 1t which is t divided by 1, 2 by 3, again here e power minus t sine, this time 2t divided by 2. Fine. So 2 and 2 we can cancel out, so we can take 1 by 3 e power minus t common, we are getting sine t plus sine 2t, sine 2t. Fine. I hope you enjoyed this question, because it was a lengthy question. I must say this was lengthy because we just use 4 pages, 4 digital pages to be precise. So let's review this question once again. Take Laplace transform on both sides, use the formulas which I already made clear to you, the tricks also, then simplify it, then take inverse Laplace on both sides, then apply the partial fraction which is the lengthiest portion of this question, and the most problematic also, because you can create mistakes here as I did, as you saw. Now in the last thing, just use the properties of inverse Laplace and get to your final answer. I hope you enjoyed this. Thanks and have a very nice day.